What I am about to talk is a very controversial subject for science, but it demands science because it's a too long time that this phenomenon occurs in the world since many decades. Uh, a lot of hoaxes, disinformation, and whatever have been spread everywhere in the world, giving an idea of a phenomenon that is not serious, that scientists would not be serious to study it. In reality, there are a lot of hints that make us think that maybe some kind of very important science can hide behind this phenomenon. This is about the so-called UFO. UFO means unidentified flying objects. It doesn't mean extraterrestrial spacecraft. There is something in the sky. It is possible to screen a lot of cases in the world, and there is a residual, more or less something like from 1 to 5% of cases that cannot be explained. The duty of science is to explain what we don't know yet, because science is also and most of all exploration of reality. It's something like a lantern in the darkness. So there is a duty that we have. I am working on this research in a parallel way since at least 25 years. I've been publishing many papers, also mostly technical papers, about the subject, gave many conferences, and most of all carried out missions to how to say hotspots in the world using instrumentations, because this is the point. The main point is that the only science that we can do about these phenomena is the science that uses measurement instrumentation. Without that, namely without numbers, we cannot do any science. So it's a problem because it's not like to study the stars. Stars have fixed coordinates, so it's very easy to find a star and to keep it inside the view field of the telescope and take our photometric and spectroscopic data. In the case of so-called UFOs, this is not possible at all, as the phenomenon is random occurring, and so it's very difficult to predict it. But my experience, also interacting with many colleagues in the world, tell me that there are several places in the world in which the phenomenon occurs more often, where the phenomenon is recurrent. So we have to take that chance to put our instrumentation just there, and so some areas in the world could be considered laboratory areas. And that's what I will speak mostly in this lecture. And I will start from some statistical consideration which can guide us to a given area of reoccurrence of the phenomenon. I will speak about the use instrumentation and measurement procedures during previous projects which were involving automatic station and also manned mission on the field. One of my main goals is just to show that we have since quite a long time a know-how experience on what to do and how to proceed in this kind of research. Of course, I will discuss about the importance to distinguish the noise from the signal in optical spectroscopy, and not only that, but the optical spectroscopy, as I will show you later, is probably the most important technique for measurement of the phenomenon. I will mention the so-called CTV project and its important connection with measurements of UFOs. CTV is just stands for search for extraterrestrial visitation. This is a branch of SETI, and I've been publishing several papers, technical papers here too, but this is not um, the place where I can go in depth in it, but I have to mention that because there is a connection. Of course, I will speak about the physical parameters that can be obtained using measurement instrumentation. I will speak about the important questions that could be answered, at least in the first phase of research. And there will be a list of priorities and discussion of how to proceed and what the strategy might be in this research. Well, I've been studying quite a lot the problem, and I wanted to see how much and how the phenomenon is spread all over the world. And so this is the first map in Europe mostly, and Africa, India, and Asia. You can see there are many points in which the phenomenon is reoccurring, much in Central Europe, but also Italy. And if you look at the United States map, you can see that there are a lot of places, a lot of spots to investigate, and of course also in South America and in Australia. This distribution of events is not really the real distribution, but it is affected by the capability to obtain information, and of course this is much more diffused in the most technological countries. But anyway, we have a precise location of those places where we could put a measurement instrumentation. So this is a collection of photos of UFOs, of structured UFOs, so something kind of like flying machines whose origin we don't know at all. Probably most of these are hoaxes. You know that with a computer it's possible to build up a lot of fake, but it might be that some of them are not fake, and the role of science is to study also this kind of structured, featured phenomena that look piloted by someone. But this is not the most diffused phenomenon. I will show you that there is a lot of areas in the world where a very strange natural plasma-like phenomenon is occurring very often. So we want to start to study that, and I will show you that they are very important because of the energy that they are able to produce. And the energy factor is crucial for our science, but also for our life. So it's important to study them. In few words, we have two kinds of phenomena. One kind of a natural light, plasma-like phenomenon, and overlapped with sometimes structured phenomena. We don't know at all if these phenomena are connected together, why this overlap occurs, but we know that we have to study both in great depth. Okay, I did an experiment 7 years ago, um, thanks also to the help of, uh, of, um, of some people that were sending me data, in particular our watch from Canada, and I liked to put the data coming from our watch and also mostly from a New Fork. Um, I'd like to put the data on practically on a chart, and I wanted to see how the phenomenon changes in time from 1950 up to 2010. You can see that if I take into account the witness cases, because these are witness cases, not measurement, if I take into account witness cases that occurred in 3 different states of North America, what I can see is that there is a very specific distribution. You can see that there is a sharp increase of the number of phenomena that were seen starting from 1995. But this is, people would say, oh, we are assisting to an invasion. In reality, the situation is not so. The situation is that these data are affected by a selection effect due to the fact that from 1995 mostly, maybe also a bit before, there was a very wide diffusion of internet and of mobile phone. So there was a sharp increase of information, the capability to get information and to spread information. So you can see that if you look at the last part of the curve of these 3 states and you compare with the way in which the cell phones increase with the year, well, it matches quite strictly. So this is a selection effect. This is not that Earth is being invaded in the last decade. So what we see here is not real. At the same way, I spoke about the time distribution of the phenomenon. If I put all the data on a map according to longitude and latitude of the 3 states, in this case the New York state, the Ontario state, and also the Connecticut, but this one is specifically the New York state, I noticed that there is a lot of places in this part of USA in which unidentified anomalous phenomena, that's another way to call UFOs, it's a more politically correct way, but it's not important for me, because I consider UFO a good term as it was invented by Professor Allen Hynek. That means not spacecraft, but unidentified, something unidentified in the sky and sometimes on the land. So it seems there is a lot of places where UFO have been seen. But if we compare this witness map with a map that shows the distribution of a population in that place of USA, you will notice that the number of witnesses increases with the number of inhabitants. So this distribution is not the real distribution of UFOs, but it's how to say, weighted by the number of inhabitants. The real distribution is this, and this results from the ratio that we can have between the number of witnesses of one kind of a UFO phenomenon and the number of inhabitants. What happens? It happens that the most favorable cases are not those cases like a large city like New York, for instance, but rather small hamlets of a few thousand inhabitants where there were a lot of UFOs. So we are sure that something happened there, and you can see how the number of lights decreases, but this is more real. This is a good statistics that helps us to restrict the investigation specifically to those places where then we could decide to bring measurement instrumentation. This was only one part of America. It was an experiment because there are several other hotspots in the USA, but and also in the world. What I found is that this is a big, most important place of UFO, and it is just more or less in the Hudson Valley. So, see, if we consider New York State, Connecticut, and Ontario, we find that the Hudson Valley is the most important, and more or less is around the Pine Bush place. So this was an experiment. The goal of this experiment was to see how statistics of witnesses can help us to use instrumentation. Clearly we have to choose something, a place, and that place, the only way to choose a place where to put instrumentation is just by witnesses. And so we did. There is a lot of witnesses and important catalog, and this is a good way to proceed. In fact, I published a big paper, almost a book, that is published on the NARCAP webpage, a famous organization in USA, directed by Dr. Richard Haynes and his collaborator, Mr. Ted Rowe. Here we have the ideal instrumentation that one should place in those areas where the UFO phenomenon occurs most often. This is optoelectronic instrumentation of military kind, such as the one that you can find aboard military airplanes, helicopters, or something like a counter-air systems sensors from the ground or from ships. This would be the ideal platform, automatic platform, that is able to track and to take recordings about a phenomenon. Why do I am showing this? I'm showing this because I have already finished to tell you how statistics of witnesses is able to help us to use instrumentation. Well, the ideal instrumentation would be this, and the goal of this instrumentation would be to find how the physical parameters, like energy for instance, changes with the wavelength of the phenomenon, how it changes along a surface of the phenomenon if it is an extended phenomenon like a structured object, and how all this changes with time. This is exactly the same philosophy in astrophysics, where through the variability in time and also in space of a celestial object is able to tell us about the physics that is going on there. But with this kind of anomalous phenomenon, we do exactly the same physics, because what we do is just photonics. We measure photons in several ways: photometric wave or spectroscopic wave, along a very wide wavelength range. So it means that it's not only in the optical, but it can range also in the radio wavelength, from VLF or maybe also ULF, ELF, VLF, up to the microwave part, and then down to the infrared, to the ultraviolet, and in case also X-ray. So this is exactly what we are currently doing in astronomy. So there is no new physics. This is absolutely classical physics, and if we find out a way to track in the air this kind of phenomenon, possibly using a radar tracking system or a video camera, then if we are able to do that, we can take a lot of data, and also very good data, because these phenomena are not far away, thousands of light years, but they are just here, sometimes also a few kilometers away from the observer. So the light, if the phenomenon is very luminous, the light is very much, and when the light is very high, the signal to noise ratio is very good, and the data are even much better than what we can obtain in astronomy. This is a paper which I did with Professor Erling Strand, director of a project at Stalin in Norway, where I carried out some scientific missions. This is a booklet that can be found at the Østfold College in Norway, and it says a lot of strategies that according to the possible theories to explain the phenomenon, there are several ways, procedures, through reasonings and also flowcharts, very detailed flowcharts, procedures able to prove or disprove a given theory. So this booklet is quite important. It's old, 20 years ago, but it's still very useful, at least to show the philosophy of the problem. These other two papers are quite important too, because they show what kind of physics can be obtained from these phenomena using military optronic technique matched with astrophysical techniques. The other paper was published on a physics paper, tells the same, but specifically to the hypothesis that UFOs are of extraterrestrial origin. These papers were published yet about 20 years ago, and they are very, very actual and very important to read. This is a very much more recent paper in which I make a resume of what we know about strange light phenomena, the data we have taken, not only statistically but also data taken on the field through missions that we carried out somewhere in the world, in particular to Stalin in Norway, to the Ontario Lake in Canada, to Ireland in the Boyle area, and to the Arizona desert, and finally in two areas in the northern Apennine in Italy, just where I'm living. And now, just showing to you an example of a very basic instrumentation, what what we have been using mostly for missions on the field that are manned missions. And just to give you an idea of what we have been doing, we were using a very high level DLSR camera, both for photography and for spectroscopy, using spectrographic grating, using an infrared filter and a polarizing filter. At the same time, we were using a VLF receiver, this one for instance, connected to its software, and a sort of a very basic magnetometer, and we were taking the data all the time. This is one example of a spectrum of a street light, of a sodium light, just to make a testing of focusing, of resolution, and so just to give you one idea. So the philosophy of the project is simultaneity, namely to observe the phenomenon simultaneously using different instruments at different wavelength. This is the same philosophy that is used in astronomy. Okay, this is the minimum concept to measure UFO phenomenon. If one is lucky, it's possible to take very important data. And we got something. This is just an idea of our field work. This was in Canada, Ontario, with a portable computer and also VLF detector, magnetometer, Geiger counter, and the camera with a spectrographic grating. This is an example of what happens when something luminous moves in the sky. In this case, it was an airplane. You can see that it spreads all the spectrum. Of course, we can take only one row or a few rows, and we calculate the average. And this is an example of the quality of the spectra, which are between low and medium resolution. You can see, you can distinguish emission lines and absorption lines of, in this case, street lights like a sodium light. And here we are in Norway, and these are images that were taken in 1984 by the group led by Professor Erling Strand, and were very famous because in 1984 there was a huge flap of the phenomenon there in Norway, in central Norway, that lasted about 40 days, and a lot of measurements were taken using the more or less the same philosophy, the same procedure that I told about. Several instruments using also a radar, VHF spectrometer, spectrographs, telescopes, a lot of things. Later, Erling Strand, together with Professor Björn Gitlehauge, built up an observatory, this one, where they implemented several instrumentation, starting from very good video camera, radar, magnetometer, and all the rest. This group, Project Stalin, has been really the pioneering group for this research, and it's probably the most important in the world. And now it's going on its researches, and it extended the research also to the teaching to students using the science camp. So students learn how to make physics, driven by the interest and the fashion that the phenomenon creates to them. So there is a motivation to do that, and Strand and Hauge are doing a very good work now with equipped with more instrumentation than the previous years. This is an example of the instrumentation that we brought to Stalin in collaboration with the Norwegians. We had a lot of instruments. I am not listing them, and we have used many of them. and I personally have carried out 4 missions to Norway. My engineer colleague of the NAF did other missions with a technological goal, and so Italy has a long dated experience in this kind of research. Just to show to you what we saw and what we documented, this is an example of a light in the sky that was seen exactly here. This is my photo, which I took in summer 2001. This is a enlargement, and this is the point spread function of the image. This one is a statistics that I did on the space distribution of the phenomenon in the sky. The white balls, it's the moon, of course, in many periods of the year, and the real phenomenon is the yellow light, that is artificial color, but it shows that there is no preferential path of the phenomenon in the sky. The phenomenon is equally distributed in the sky, but not only in the sky. Many times it's just on the ground. Here I took the data from Project Stalin 1984, and I can see that there is a correlation, a smooth correlation between the increase of the magnetic field that could be taken by the magnetometer, and the number of luminous events, luminous phenomena. And here there is a statistics with the hour interval, with the distribution during the year, and that also shows that there is no correlation with the solar activity. In fact, you can see that the circles here are not correlated with the bars, and also along the years there is no correlation with the solar activity. It seemed it was a correlation, but it was only 40 days, and possibly it was just a coincidence. But if you take a long time, there is no correlation with the solar activity. Well, I am not here to discuss the theories here, because this lecture is not aimed at presenting an erudite vision of the phenomena of this research, but it's more pragmatic. It is aimed at showing how the phenomenon behave and what we can do in order to study it. This is an example of my work, my research, with that shows several phenomena very close to the ground. In this case, you can see that it changes colors. Sometimes there are clusters of phenomena, and here we have another kind of phenomenon that is changing shape, of course also luminosity, because the phenomenon is changing not only shape but also intensity, so it's kind of pulsing all the time in an irregular way. And this is strange because sometimes it has geometric shapes, but this doesn't mean that it's solid, but the light is just rectangular in this specific case, and you consider that here we have a lot of pixels. We have not 4 pixels, but we have hundreds of pixels. And the same was confirmed also using a conventional camera. This was a frame taken from a professional video camera. There were several kinds of phenomena, and Professor Strand can tell you in detail how is the zoology, let's call it so, but also very weakly luminous phenomena, like this one, that was very close to us, and that resemble, through the point spread function that you can see, the distribution of luminosity, uniform, a sort of solid that is illuminated by light. In other cases, they look like just plasma. And this is a way in which the phenomenon pulsates. So you can see it's something like an electrocardiogram. This is the luminous intensity versus the number of video frames. This means times. The phenomenon starts, goes up and down. It tries to turn on. At the end, it succeeds, and it reaches a more or less constancy and suddenly fade out. This is a spectrum of a phenomenon that I took, and this shows a continuum spectrum that resemble quite a lot the LED lights. Well, this doesn't mean that the phenomenon is artificial. This simply means that the light behave in that way. I cannot enter into detail now, but I can tell you that also some kind of natural phenomenon can produce that. Of course, I have put here a reference to my technical papers, because whoever of you wants to go in depth can study those papers where also theories, hypotheses are discussed. This is just the distribution, like the same chart that I showed before, and it shows that the received luminosity increases with the surface area, and that the temperature remains constant through the spectrum, and so the emitted power increases only with the square of the radius of the emitting surface, being the temperature constant. This is a law that I found looking at the way in which light behaves of the phenomenon while the phenomenon is pulsing. And this is the behavior of the phenomenon. This happened not only in Stalin, but also in other places of the world, like the Min in Australia, Baulia. And what I can see here is that the phenomenon is changing its light all the time, with a pulsation rate of the order of a second or even less, sometimes more. The increase of luminosity is not due to the inflation of the light. There is no inflation, but it is due by the fact that around a nucleus, it's something like a nucleus of light, of plasma that forms, suddenly many other plasma balls form, cluster together, and when we see it from far away, what we see is that the light is bigger, and the light changes practically only due to the increase of the radius of the complex of the cluster, that from far away we cannot see resolved all these balls, but from far away we see only that. This is corresponding with the maxima of the received luminosity, and this is very interesting to study. We have seen also peculiar VLF phenomenology in the very long frequencies, and there were Doppler effect of something like if particles that were approaching, alternatively or receding from the observers. This helped me to elaborate a model very similar to a pulsar in astronomy, of something that is rotating very fast, and where the rotation axis is misaligned compared with the magnetic axis, assuming that high energy particles are accelerated along the magnetic axis. So this is just an hypothesis, of course, but sometimes astrophysicists from the data, how they are able to imagine some possible scenario. Of course, this can be confuted or proved. It's not proved yet, but it's just to look to show you what is the philosophy of research here. Concerning the Stalin phenomenon, there is an important paper that I published in 2004, so 13 years ago, but it's always actual and gives a global description, technically, of the phenomenon that was taken, and also all the procedures that were used, in particular to calculate the luminosity, about 20 kilowatt of power, once when we knew the distance using several ways and the apparent luminosity, so we could calculate the absolute luminosity of the phenomenon. This is very important because this is high energy, and when we see high energy, we have a feeling that if we are able to reproduce this kind of phenomenon in a lab, we could have an alternative source of energy. So the energy problem is very important, but because before reproducing the phenomenon in a lab, we have to understand fully the physics of the phenomenon. And what is very important here is that the main question mark, the main mystery here is to try to understand what is the center force that is able to maintain the phenomenon luminous for so long time, because sometimes the phenomenon lasts, just pulsating, just turning on and turning off, but lasts for a long time, up to some hours, and we don't know what is the physical mechanism that make the phenomenon be bright so long time. So we of course we thought of several possibilities. I'm not here to discuss about the physical theories, but I only want to stress that we have to know what is that field that is able to confine the plasma inside, because normally a plasma can be produced by the ground, like from the piezoelectric effect, for instance. But then it ionizes the surrounding air, and then, following the thermodynamics law, it tends to expand immediately, so that the thermodynamic system cools adiabatically, and it turns off almost immediately because the temperature goes down suddenly. In this specific case, the temperature remains constant for a long time. So we want to know what keeps the phenomenon confined, what it can be, whatever. It's not yet time to tell what it is. Several theories have been proposed. At first we thought of a central force, sometimes also of a mini black hole inside that is able to confine and collect the plasma without making it expand, but just confining it in a self-sustained fashion. This is an idea, but I wanted to show this to you because I need to show you what is the philosophy of research that we are following to make this research. Okay, in addition to the Stalin phenomenon, we have had also other observers. These observers are, I cannot mention all, but there is NASA engineer James Bunnell, who is doing a very important work in Marfa, Texas, where there is a strange phenomenon. There were attempts of measuring the electromagnetic field and the magnetic field by Professor Strand in Australia, in the area of Min Min in Australia. There's been important work in Yakima Indian reservation by electronic engineer Dave Eckers, and there has been also use of instrumentation by astronomer Dr. Eamon Ansborough in Ireland. I know all these persons, so I am able to be in touch with them immediately if we want to do something together. This is one image taken from a place in the Apennines of North Italy, in particular Solignano, where we got a light phenomenon, and sometimes we got also very strange VLF signals that were lasting for 20 up to 30 minutes, and this is a very interesting place where to take measurements. Concerning the VLF, it happens that sometimes they happen while the phenomenon is on site, but most of the times they happen when nothing is in sight in the sky. That's a good reason to propose to use infrared. I mean something 30,000 angstrom, so the medium infrared, because I'm sure that when VLF signals due possibly to the phenomenon are seen, there is also something that our eyes cannot see. But if we use an infrared detector, like a thermal imaging camera, we could do that. This is some images that were taken by our mission in the Arizona desert, and we had a lot of instruments there, and I was dedicated to the optical part, and these are two examples of what came out there. This is in the Monte Sibillini, exactly in the heart of Italy, where sadly a big earthquake destroyed the little hamlets there. Also there were strange phenomena, a lot of electrostatic charge from the VLF, and very strange light phenomena that were seen also at the daytime. So this is an important place where to place instrumentation. And this one was in our region, which is corresponds to the south of North Italy, just on the northern Apennines, where strange phenomenon appears on the top of Pietra di Bismantova, these lights. And this is an enlargement, and this is a better image that was taken by astronomy amateur Nicola Tosi, who is doing, and he has been doing a lot of good work in taking the data in the area. I went there 2 times. I was able to take a spectrum and also VLF, but unfortunately the light was quite weak. This is a very important place where to place instrumentation, both manned instrumentation and automatic instrumentation, and I will tell you the philosophy of the research. This is an impressive transient signal that appeared and lasted about 20 minutes in the Ontario area, in the place of Cheltenham Badlands, and I was collaborating with a group whose name is Orbwatch, that is doing since 1997 a very good sky watching work. This was a very strange signal that has not been explained yet. Of course, in our data bank we have a lot of we have a database of all the signals that are produced naturally by the ionosphere or by man-made signals. So we receive transmitters. So we have a big data bank that can help us to distinguish the signal from the noise. This signal that was extending throughout the frequency band 15 kHz was not explained yet, and we are going there again, hopefully bringing more instrumentation in the area, in the place. So I've given to you an idea of how the phenomenon behaves, and I need to stress the importance of optical spectroscopy, which is of course not the only technique that is used, but which is very important, and I will tell you why. These are spectra that were taken by me using long focal length and applying a diffraction grating in front of the lens. These are spectra of street lights, and balls that you see, colored balls, are just emission lines. Clearly, if you are able to identify the emission lines, you can tell what kind of chemical element. But not only that, you can also tell what is the temperature, pressure, and density of the gas that is able to produce those lines. You can have a spectral line only if the temperature and the density have a certain value. So we can go back, measuring the emission line, to the temperature, pressure, and density that has produced them. Clearly, it's very important that the resolution is the highest possible. For instance, resolution, I compare a very low resolution spectrum of a street light of the mercury kind in this case, and you can see that if you use too low resolution, you cannot distinguish at all two lines that are very close. In this case, you see only one line. In this case, too, you see two lines, but here you see only one. Resolution is very important. It's very important because there are some kind of phenomena, like the Zeeman Effect, which is caused by a very strong magnetic field. I mean something of 1 million Tesla. One strong magnetic field is acting inside the plasma. When we have a very strong magnetic field, every spectral line is split in two parts, and from the difference of the wavelength, of the central wavelength of the two peaks, we can deduce directly the intensity of the magnetic field that is producing this doubling. So this is a very crucial physics result, and we want to reach that because we could understand a lot through spectroscopy, not only temperature, pressure, density, spectrochemical identification, but also magnetic field intensity. If we, for instance, are able to take a sequence of spectra in time, and we see how the difference in wavelength between the two peaks of the split line changes, we can deduce the physical mechanism that creates what we see. So it's very important that we aim at the highest resolution possible in spectroscopy. In fact, I have been testing also other kind of spectrographic instruments that I show you. For instance, this is a normal grating on the above on the left. You have a great spectrographic grating, and this is the possible spectra that can be obtained using 300 millimeter of focal length. This is a prototype of a much higher resolution spectrograph that was projected by Dr. Ron Masters, which is able to offer two options. A first option is low resolution spectroscopy but with a much better low dispersion spectroscopy, but with a much better performance in terms of resolution. In fact, if you compare the spectral lines, here are just lines compared to the balls that you can see here. So it's a very excellent instrument, and you can see, if you Google Dr. Ron Master's spectrograph, you will find its patent, and you can inform about the possibility to buy that. I bought the prototype, one of these prototypes, but this one is not the only options regarding Ron Master's spectrographs, because there is another option that is high resolution, relatively high resolution, at least 2 order of magnitude more than what I was able to obtain with the normal resolution. In this case, the spectrum is spread over several orders, and I show better here what I mean. These dark lines are just the Fraunhofer lines of the sun for testing. So you see that in this case you can have a lot of more detail in spectral lines. You can resolve 2 very close spectral lines, and at the end you are in a condition that you can really measure the Zeeman splitting of the lines if a very strong magnetic field is present. In this other case, you can see just the spectrum of street lights, how it appears when you use the high resolution option. You can see these, or you can see the emission lines that are spread in at least in 7 orders. Clearly, there is a software that helps us to rectify the spectrum and to connect all the orders together in only one very high resolved spectrum. I'm speaking of spectroscopy. Well, this is a very nice result that was obtained with a low resolution grating by a group in North Italy, near the area of Rovigo in Veneto, where strange phenomenon is occurring very often, and the group is led by astronomy amateur Jerry Ercolini, who is doing a very nice work with admirable constancy and competence. They have been informing me very constantly, and this was a spectrum that was obtained 3-4 years ago, that shows how spectroscopy is important in making this research. You see, there are several peaks. These peaks are emission bands, namely clusters of emission lines. Those bands are due to oxygen. I did the analysis after calibrating the spectrum. They are oxygen lines, and this shows that the phenomenon is a plasma, which is the result of ionization of some source that ionize the air. Clearly, from this, we can measure the number of atoms of air, of oxygen, that concurred in creating the spectral lines, and from that, using several mathematical techniques, calculate the temperature, the pressure, and the density of the source of temperature that created this spectrum. This is exactly how, the way in which we proceed in astrophysics, a way in which we can apply astrophysical methods to this kind of phenomenon, where simply we measure the light. So it's a question of photonics. It doesn't matter if the light is very far away or if it is here, the physics exactly the same. So this is just to show how important. Well, here is a paper that I published 7 years ago, but it's quite important because it shows how to say, we make a review of all the work that was done in all these years, and also focusing on the gaps that still were present, so we are conscious of what can be improved, of what can be added, and what can be avoided in this kind of research. I want to show now a new project, the most updated idea to make an automated instrumentation. Something like that. The basic concept of an automatic station for UFO monitoring involves a main unit with essential instruments that I will describe in detail afterwards, an electromagnetic unit, and an optical specialized unit, all connected to a computer. And here informatic system is very important, not only to save the data, but most of all to trigger the system, the entire system through a computer, something that is able to trigger automatically via informatic means all the instruments, so that they can work alone without any need of personnel on the field. Now in more detail, I want to show what is the use of these instruments. The main unit contains an electrostatic detector, this one, which is able to calculate the number of electrostatic particles per second, a weather station, which is able to measure all the atmospheric parameters like air temperature, pressure, humidity, wind speed, clouds, etc. Magnetometer, magnetic field intensity, in 3 axes, X, Y, Z components, of the flux gate kind, so something very sophisticated. And the media magnetometer is very sophisticated and also portable, and an all-sky camera that is used for several tasks. The main one is photometric and photographic, and also video, which is able to measure the apparent target luminosity and color, the light surface distribution of single targets if they are extended, so we can calculate the point spread function, the angular speed of the target in the sky. In fact, we are connecting a video camera to the wide field lens, to the fisheye lens of the all-sky camera. But we can use this instrument also spectroscopically for applying to it spectral grating that allow low resolution spectral grating that allows us to obtain the spectrochemical line identification, and clearly if there are lines, also the intensity and the equivalent width of the spectral lines, from which it's then possible to calculate, like I told you before, the number of atoms of a given chemical element that are excited by exciting cause that raises the temperature of the air. Clearly we can measure also the flux of the continuum spectrum, when the spectrum contains lines or not. The flux, the way in which the flux of the continuum spectrum varies, can furnish to us several additional important information. Now we pass to the specialized unit. The EM unit is devoted to the measurement of the electromagnetic field, in particular on a very wide wavelength range, ranging from the VLF ELF, so in the very long wavelength, so very low frequencies, in the intermediate VHF frequency of the order of some megahertz. The first one in VLF is from 10 to 10,000 hertz, and in the UHF spectrometer, namely devoted to a measurement of microwaves, and in this case the range is from 900 megahertz up to 10 gigahertz. So this is very important, because in that way we have a total coverage of the electromagnetic spectrum at the same time in which we are taking the optical data and magnetometric data with the main unit and also with the other specialized optical unit. Clearly we can use a Geiger counter in order to measure the intensity of the radioactivity emission, namely alpha, beta and gamma particles. And then we have the physical parameters to be obtained by the optical unit, which is a specialized unit that contains an optical radiometer, which is able to measure electromagnetic radiation intensity in the optical, in the infrared and in the UV. We have a high sensitivity video camera that is able to measure kinematic characteristics of the target, like speed, acceleration, and changes of directions, but also the angular speed of the target in the sky, apparent target luminosity and color, and the light surface distribution as a point spread function. Then we have a high sensitivity video camera that is connected, it is not used for imaging like the first one, but it's used to obtain spectra of the light phenomena all the time. So it's not a photograph, but just video of spectra, and this is very important because this can help us to see if and how the spectrum varies. For instance, if the spectral lines change amplitude, appear, disappear or not, because this is a very important physics information that we can obtain. And clearly we can obtain spectrochemical line identification, intensity and the equivalent width of spectral lines and their variation in time, as I told. But we use also DLRS camera plus a shell grating. The shell grating is simply the high resolution spectrograph by Dr. Ron Masters. It's a very special spectrograph because there is no slit, so you don't need to put the light inside the slit like we normally do with telescopes when we make spectroscopy. But in this case there is no slit, there is a wide field, and it is able to catch the light within an angle of about 45 degrees. So if the light is moving, we can anyway obtain a spectrum of it. But in this case we can obtain a spectrum of very high quality because it is a high resolution spectrum. This is called a shell grating, and with it we can obtain high precision, intensity and the equivalent width of spectral lines, morphology of spectral lines, which is very important because from the morphology, if we see that the lines are split in two parts, this means that that may be due to the Zeeman effect caused by very strong magnetic field, and we can measure the magnetic field intensity from separations of the two peaks. But we can also measure possible line, blue or red shift in case of a high speed of excited gases, but a very high speed. We cannot exclude that, and also possible rotational broadening of the lines due to the rotation of the possible rotation of the plasma, if the plasma is very strongly rotating, like in the case of the models of some ball lightning physics. And we can also use specific cameras that are able to obtain photographs simultaneously in the optical, in the ultraviolet, and in the infrared. That is quite important and very interesting. This other instrument is very of fundamental importance, quite expensive but important, a high-speed video camera of the high-speed kind of the Olympus, for instance. In this case, we can obtain 10,000 frames per second, and so we can be in a condition to build up a light curve of the light at a very high time resolution. This also can furnish us a lot of physics information about the dynamics of the phenomenon regarding its light variability, which in case should be connected with the variability that is measured by the other parameters like spectrographs or so. So this is the ideal optical unit, electromagnetic unit, and main unit is the ideal system that can help us to furnish a lot of data. To them, in the future, we could add a gravimeter able to measure possible changes in the gravitational field intensity, and most of all, a thermal imaging camera in the medium infrared able to obtain an image of the phenomenon in the range between 2000 and 3000 angstrom. What I want to tell you now is very important, because what we are planning to do is exactly what we are currently doing in the astrophysics of variable objects like variable stars, closed binary stars, supernovae, quasars. These are all variable objects, and the procedural steps that are used to study them, it's making simultaneously coordinated observations using different kind of instruments that offer a picture, a very wide picture all over the wavelength range. For instance, if we wanted to observe a gamma ray burst, we can use not only gamma ray telescope but also X-ray telescope, optical telescope, infrared telescope, ultraviolet telescope altogether. If just observing all these things simultaneously, we were able to understand what is the central engine of quasars in the nuclei of active galaxies, and also the pulsational mechanism in Cepheid stars, for instance, or pulsars or so. So the philosophy is exactly the same. We want not only to have a static picture of the phenomenon, but also a dynamic picture of the phenomenon, which is the one that is able to tell us the physics of the phenomenon, whatever the phenomenon is. If it is a natural phenomenon, we have a thing. If it is an artificial phenomenon, we have another thing, including potentially the propulsion mechanism that is moving a possible airship that is not human, and we can deduce a lot of data from the sort of back engineering. Clearly we have not the object in a hangar, but we can observe from in distance what happens, and to try to reconstruct the physics of this kind of engineering that is flying in the sky. We cannot exclude anything. This is the best philosophy for science, and it's exactly so that we want to proceed just aseptically. There is some questions that should be addressed, and I can mention them. And the first question is what are the questions, problems this project will be designed to address? Well, the answer would be natural, man-made or exogenous nature of UFO phenomena and their physical mechanism. So we can answer to this. And not only that, but we can exclude all the possible prosaic causes, the man-made. So we have this system is able to allow us to exclude, to eliminate the noise and to take the signal, only the signal. And this is extremely important. This is something that the witness of a UFO phenomenon is not able to evaluate. What were the limitations of the previous efforts, of the previous missions? Well, there was a lack of sufficient automation, of continuity of functioning, and of instrument completeness. The previous instruments were also good in quality, but they were few. They were not the most updated model, except for something. And here we need much more. And in order to have that, we need the appropriate money funding, without which it's not possible to make a research that is respected. How does this work differ from existing astronomical networks of all-sky camera? Well, I can say it's more complex. It contains more instruments, in particular magnetometer and most of all spectrograph, that work all together. So making it work automatically is more complex, and we need the competencies of informatic engineers or informaticians that are able to implement a software that is able to pilot the instrument automatically, and also to save the data afterwards. What general types of instrumentation are to be included in a prototype? The main unit. The main unit, as you saw, is composed by practically everything, by the essential of everything. An all-sky camera, a spectral grating, a magnetometer, and an electrostatic detector. So we would start first on the main unit. We want to see how it works, and when we are sure that it is able to acquire sufficient and good quality data, then we would add the other two units, like just to add cherries to a tree, practically. Then we have what is the estimated cost for the prototype, where and how will it be tested? Well, I evaluated a number. It's about 50,000 US dollar, and it would be tested at areas of the world where the UFO phenomena are more recurrent. What are the next steps after developing the prototype device? Clearly, if everything is working, we would add an electromagnetic unit and an optical unit, and even also possible extensions of the main unit. We have to decide if to make 3 separate units or to expand the main unit with additional instrumentation. How large a network do we eventually hope to construct? Well, as large as the simplicity and the essentiality of each station, clearly. How will we decide where to place automated station? According to an accurate spatial and time statistics of scientific reports. I recall you the first example that I made in the beginning of this lecture, showing how statistics of witnesses can guide scientists to decide which place exactly would be used. Okay, and we have the last question that is clearly the most important, and it says that we have to obtain physics data. So the question is telling what is the definition of success in our research. It means identification of the phenomenon, man-made, natural, or exogenous, and measurements of its most essential physical parameters in order that we can turn this research fully into a physics research and make of so-called ufology a physical exact science. Okay, here it is a sort of resume that shows practically the strategy and the procedures that we are going to adopt in our work, and practically we have fixed instrumental priorities like optimum power source, main unit, alarm device, instrument sensitivity, data rate and PC interface, multiple video cameras, EM electromagnetic unit, instrument wavelength range, optical unit, additional instruments, and also with a consultancy with the engineering experts. So we evaluate effectiveness versus costs, security against interference and intrusions, station locations choice, scientific redundancy, data processing and analysis, hiring of PhD students. This is very important because PhD students are just graduate students, substantially are young scientists who are very, very fast in calculation, and they are very important and very motivated. Instrument completeness, station multiplicity, occasional presence of investigators, and station flexibility. So there is a lot of reasoning here. I suggest you go to the paper that is discussed, which I indicated somewhere here in this presentation. I can just make a resume of the instrumentation. So we have three units mainly. We have a main unit made of an all-sky camera, a magnetometer, atmospheric station, and electrostatic detector. We have connected to the main unit an optical unit with a single video camera, with a multiple video camera, a high time resolution video camera, low resolution spectral video camera, DSLR camera, UV, ultraviolet infrared DSLR camera, high resolution spectral DSLR camera. And then we have electromagnetic unit with a microwave spectrometer, a VLF ELF spectrometer, a VHF receiver, and a Geiger counter, all connected by a computer control that is piloting them according to any possible alarm that comes out and activates all the instruments in order to take the data. This drawing shows that I did 2 years ago the most essential main unit that we would like to use, that consists of an all-sky camera which can allow to obtain videos controlled by a computer, and which is also connected to a spectrographic optical system which can allow us to have a spectrum all the time while the phenomenon is viewed by video camera. We are able to take a spectrum of the light of the phenomenon, and also an electromagnetic mini unit that is able to measure the VLF, ELF electromagnetic field. Clearly, this is important field, but This is the optimization of a very cheap system for the main system. Clearly, I think that a microwave system would be much more important, but clearly it's a factor two more expensive. I cannot not mention the existence of an important group of scientists and scientific ufologists that has been created almost 2 years ago. This group is called the UFO Data, and it is led by Dr. Mark Rodegier of the QFOS Center that was created many years ago by Professor Astronomer Joseph Allen Hynek, and this group is devoted to the acquiring of scientific data on the UFO phenomenon, and is waiting for the complete money funding in order to be in a condition to build up a prototype on substantially the main unit that I've been showing to you. The members of this group comes from several nations. Many are PhD, many are physicists, astronomers, engineers, and other kind of scholars like scientific ufologists and so. This is the website. If you Google, you can find UFO Data, and you can see inside a lot of papers, just to show that we have at our disposal the know-how to make this research effective. So we know what to do. We know what to do since quite a long time. You can see the papers, you can see the videos, educational videos also. Please have a look inside. Of course, there is a lot of I'm also a member of the group as an astrophysicist, and I wish this group to grow as soon as possible, because this field of research is of basic importance for fundamental research, and we don't want it is how to say disregarded, as it was disregarded for so many years. This is me 2 years and a half ago, where in Paris I, together with other scientists, I gave a short version of this presentation, and we were at the CNES, Centre National d'Études Spatiaux, and in particular the JPAN, which is devoted specifically to the study of UFOs. So it was a very big congress. It was the first congress of that kind, a technical congress, and my wish is to be able, that many of us are able to bring to the next congress the first result about the physics of UFO. And here are the papers that you can read. This is a project for a network of automatic stations for UFO monitoring. This is published on the UFO Data website, and there I discuss all the techniques, the strategies, tactics that are used to build up automatic station, and all the physical parameters that we can obtain. Clearly there is all in the beginning an introduction about all what has happened before, and this is an important paper, quite recent, and this one is even more important. It was the paper I presented to the Paris CNES Japan Congress in Paris, where I show everything about what we know of the phenomenon, what we have found, what we are going to do about the phenomenon, and all the strategies. This is the most complete, and you can find this paper on the CNES Japan website, or in my ResearchGate page in my ResearchGate page there are many of my publications of astrophysics, physics, and also anomaly. You can find it all there if you have enough patience to go through. So now there is another part. I just mentioned before that we want to study the phenomenon regardless its nature. We don't want to search for aliens. We only want to see what comes out from the data, namely from the numbers, not from the chapters. So whatever it is, it can be natural, it can be man-made, it can be alien. These three possibilities must be considered, and we have to let speak the data. So, SATV, I just mentioned in the beginning, what is SATV? It means Search for Extraterrestrial Visitation, and it is a branch of SETI. It is a branch of SETI that was initially founded by some JPL, NASA JPL scientists and engineers, and that I also followed with some of my papers. And the goal substantially is to see, using astronomy-like instruments, namely telescopes of any kind, like radio telescopes and also optical telescopes or infrared telescopes, to monitor the solar system within 50 astronomical units from the sun. So it is astronomy, astrophysics is the same thing. We want to see if something anomalous is transiting inside our solar system. So this research is strictly connected with all the research I spoke about to you before this, and we have two kinds of CTV. So, but in the case that UFOs are alien, we could consider this monitoring which I was speaking about short-range CTV. The first one is long-range CTV, and it is done using telescopes. So I did some publication on peer-reviewed journals. I will show you the abstract just in a while. And what did we do? Okay, concerning the first part, little has been done. We are searching for infrared excess, object that has infrared excess that produce strange light curves that have a very high angular velocity inside the solar system. Regarding the long-range CTV research. Regarding the short-range CTV research, we did this. We are able to identify prosaic events, something that can be interpreted in a very simple way. We can identify hallucinations, deceptions, frauds, hoaxes, and fakes. We can identify undisclosed terrestrial technology in some cases, because I'm very expert in aeronautics and also in the skunk works, so I know something. Of course I can know all because I'm not allowed, but I know that something can be passed for UFOs, but it's ours. We have done a quantitative study of the ufological database. At least there has been some experiment. We have carried out a physical study of a spatially recurrent geophysical plasma-like phenomena, like Stalin and the other places where I've been. And of course we have been searching for suspect extraterrestrial visitation in some world areas where it happens very often. Clearly we do not have an evidence. We have a suspect, surely, because something happened also in our presence, but very rarely, that we couldn't explain, and it was so fast that we couldn't have time to take data. What are the results so far concerning the CTV side of this research? We now know more about some anomalous terrestrial phenomena. At least we have a quantitative description of how they behave, but we do not have the physical model that explain, for instance, the reason why their light is so long-lasting. So we don't know the physical mechanism that confine the plasma inside the center. We now know much, very much, unfortunately, about hoaxing activity concerning the UFO phenomenon, and we have also several hints about who is creating this, why, and for a long time. We know why they do that, but we are able to identify this. It is the hugest noise in this research. So far, we have no scientific evidence of an extraterrestrial visitation on Earth. This cannot be impossible. This cannot be impossible, absolutely. On the contrary, it is possible. There are several models like the warp drive theoretical engine, the wormhole possibility of teleportation. They are not science fiction, they are physics, theoretical physics. They are theoretical physics models that predicts, according to the some solutions of the field equation by Einstein, they can predict the possibility that we can, everyone can fastly cross the galaxy and also colonize it. So who says that visitations are impossible is not doesn't know theoretical physics. Theoretical physics says that it's also possible that some civilization, particularly when before their sun becomes a red giant, may have migrated using very big arcs that are called Dyson arcs, from the name of physicist Freeman Dyson. It's possible that they have put in motion artificial planetoids using more or less conventional propulsion, so much subluminal velocity, that is able to bring aboard a lot of elements, maybe also millions of people. So you could imagine them like big air carriers, and you could imagine some of the UFO that are seen like the airplanes that are launched by the carriers. So this is an hypothesis, of course, but we can test that using both a long range and a short range investigation in this particular field. These are two technical peer review papers by me. They're quite recent, 2 years and a half ago, published on the Acta Astronautica. In the first, I tried to organize a sort of viewfinder for city research, using the possibility that not only some planets around certain stars may be able to send intelligent signals in the radio and in the optical range, but also that they may be able to colonize the surrounding circumstellar environment, and so I found a lot of markings that we could find and try to organize and to how to say, optimize the time for city research only on specific targets. This other paper is more close to the investigation of UFO, and it is dedicated to the investigation of hypermotion objects, so, namely having an infrared excess, namely there are objects that they go much faster than it is predicted by the Keplerian orbiting of the planets, so it might be something else, and we can be distinguished because there are some markings that we already know how to distinguish, and we know how to find again, and they sometimes they might be the cause of the so-called false alarm in SETI, namely of signals that have been seen for a while and then they have not been seen anymore, simply because they were so fast that went out from the lobe of the radio telescope and we couldn't catch it anymore. But now I have a strategy that might be able to catch it again, and also using the new array techniques of radio astronomy like SKA techniques that might get those signals again. So just to show that as an astrophysicist I am strictly linked to the SETI side, and so I can be a very useful link between physicists who are studying this kind of strange lights and astronomers that are, for instance, at the SETI Institute. I can be a link, I can be a bridge. I know both worlds. I've been doing research in both sides, starting from astrophysics. And so we are to the conclusion the UFO phenomenon urges a scientific solution. That's absolutely important, because if we don't face the problem scientifically, we will leave this in the hands of people who create hoaxes, who create sects, and many other horrible things that get people away from a correct approach to science, to life, and to reality. There are some attempts in the past to measure the phenomenon. They have been done, but we have found some gaps that now must be filled. So knowing these gaps, we know how to improve the research, just because we have a quite strong know-how, started from Dr. Rutledge in Piedmont, physicist who in the last 70s measured with the instrumentation a strange phenomenon for 7 years that was occurring recurrently in his area. And then the work, most of all the work by Professor Ellingstrand and Professor Björn Gittleauge, who has pioneered this kind of research. I want to give a more physics approach to this. Instruments are very important, but it's also important to interpret what is processed by the data. So we have to analyze very carefully with the eye not only of the engineer, but most of all of the physicist and the astronomer, what comes out from the data. Clearly, the use of an automated measurement station for monitoring anomalous phenomena is the only system that can allow us to obtain some scientific results all the time, clearly. An automatic station must be multi-instrumented and have analytic capabilities, like the one that I've shown. Of course, it's possible not to use an automated system, but to use people on the field. Clearly, this is all possible, because this is what we have done all the time during missions in several places of Earth. But clearly, man time is not infinite, and so we can do observation, for instance, 8 hours a day for 2 weeks, but much might escape our attention. So we have to concentrate all the efforts in the automatic platform. We have physics goals, and these physics goals now are very clear because we know which instruments we have to use to obtain some result. It's very important, the side of engineering and informatics. They're very crucial for the practical realization of the station. So it's not possible to think of an automatic station, but also a manned station, without the crucial support of engineers and computer scientists. But this time it is important that physicists take the ball and the leadership, because they are they who have to discover what's behind this secret. Clearly, the location where the station should be placed must be chosen very accurately. I've shown to you a statistical way to choose the location and all that. So I think I wanted to give you one idea of our research, of our goals. I couldn't tell everything. There was no time to speak about the details of the CTV, for instance, or the details regarding the theories about physical theories about hypotheses about the luminous phenomenon. But just here, I wanted to concentrate more on the pragmatical aspect, focusing on the instruments and on the way to use them in order to obtain data. Okay, something about me. I am an astrophysicist. I have a PhD in astrophysics and I'm specialized in stellar physics. I have been doing much research on supernovae, novae, cataclysmic variables, close binary star, gamma ray burst, extrasolar planets, comets, and SETI. I am also a science divulger. I wrote 17 books about science and about the frontiers of science, and I am currently giving many professional talks in Italy and abroad. So thank you for your kind attention, for your patience, and let's hope that some wise financier listens to my words, hoping I gave a good idea about what we want to do, because this research must not be anymore the frontier of physics, but must become physics, because it could give us a lot. It could give us hints about the energy issue, which is totally important. It could help us to find maybe new laws of physics. Clearly, we don't know everything, and maybe we could demonstrate that we are not alone in the universe.